Assalamu alaikum everyone. Welcome in the second experiment at my lab. Today we're going to talk about oxidation of aldehydes using base catalyst. This reaction called Cannizzaro reaction. So any aldehyde without alpha hydrogen has no alpha hydrogen in the presence of concentrated alkali will undergo self-oxidation and reaction to produce a mixture of alcohol and the salt of carboxylic acid. So this is the main idea of the Cannizzaro reaction. 2 moles of aldehyde without alpha hydrogen in the presence of concentrated base will produce alcohol and the salt of carboxylic acid during the oxidation reduction process. So let's take benzaldehyde as an example to explain the main idea or the principle of Cannizzaro reaction. We will use 2 moles of benzaldehyde, which is aromatic aldehyde without alpha hydrogen, no acidic hydrogen, in the presence of concentrated KOH or NaOH will produce benzyl alcohol and potassium benzoate. Let's see the mechanism of this reaction. We need 2 mole of same aldehyde without alpha hydrogen in the presence of concentrated base. At the first step, hydroxide ion will attack partially positive of the molecule number 1, partial positive of carbonyl to produce this intermediate. This hydroxide will protonate the hydrogen in the second step to produce double charged intermediate, and this is negative charge will reform carbonyl group by losing or by accepting the the hydrogen atom with bond to attack the second mole of benzaldehyde, because here is partially positive, and of course break the pi bond of carbonyl group. Now have a look again to this important step. The first mole or the first molecule will expel or losing hydride ion. The second one will accept this hydride. So this is called oxidation reduction process. The reducing agent and the oxidizing agent, and the process called reduction oxidation process. So decreasing the hydrogen atom, so this is under oxidation, it is reducing agent. This is increasing the hydrogen atom, so this is under reduction, this is oxidizing agent. And of course both of them will convert to benzoate and benzyl alcohol. Again, we need 2 mole of same aldehyde without alpha hydrogen in the presence of concentrated base. This negative charge of base of hydroxide ion will attack partially positive of aldehyde of mole number 1 of molecule number 1, and the pi bond in the carbonyl group will break to give negative charge on the oxygen. Another hydroxide ion will expel or will extract or deprotonate the hydrogen from hydroxide to produce double charged ion intermediate. This double charged ion intermediate will reform the carbonyl group by expel or losing hydride, and this hydride will attack the second mole of benzaldehyde to produce potassium benzoate and benzyl alcohol. There is another suggest mechanism. From step 2, this negative charge, when reform the carbonyl group again, so directly when make a double bond, this hydride will leaving to attack the second mole of benzaldehyde, and of course with the same products will produce benzoate and benzyl alcohol. Because we use 2 mole of same aldehyde of same starting material, the percentage yield of this reaction is very low. The maximum yield for this type of reaction is about 50%, which is very low, because these 2 moles will convert to 2 compounds. So both of the products, the maximum percentage yield of them will be 50%. To increase this yield, we will use another aldehyde or different aldehydes. So this reaction called crossed Cannizzaro reaction or mixed Cannizzaro reaction, by using 2 moles of different aldehydes without alpha hydrogen in the presence of concentrated base will give alcohol and the potassium or sodium acetate, formate benzaldehyde without alpha hydrogen, formaldehyde without alpha hydrogen in concentrated base condition will get benzyl alcohol and potassium formate, so alcohol and salt of carboxylic acid. To increase the percentage yield of the product, we used cross Cannizzaro reaction, because we use 2 different molecules of starting materials, not like Cannizzaro reaction, which use 2 mole of same compound, so the percentage yield of a product will be low. Then let's move to the procedure of this experiment. It's very easy. The part 1, we need round bottom flask. To this round bottom flask, weight and add 7 grams of potassium hydroxide and dissolve it in 6 ml of water. Then cool the round flask by tap water, because the desulfurizes of potassium hydroxide in 6 ml of H2O releases heat. Then add to this base solution, this concentrated base solution, 7.5 ml of a pure benzaldehyde as a starting material with shaking by hand. Shake the solution very well until the solution became very thick, oily, like oil. So allow this mixture to stand overnight, and this time the reaction should be complete, and the mixture inside the round bottom flask should contain benzyl alcohol as product number 1 and potassium benzoate as product number 2. In the next lab, at part 2, we have to separate these products to purification our products. To this mixture, which you produce from part 1 in the round bottom flask, add 50 ml of H2O to dissolve the potassium benzoate. The salt will dissolve in water. Then transfer the solution, benzyl alcohol, potassium benzoate, maybe another impurities, with H2O. Transfer the solution to the separatory funnel. To the separatory funnel, add 30 ml of ether and shake well to extract the organic materials. So the salts will dissolve in water and the organic compounds will dissolve in ether. After 10 to 15 minutes, separate the lower layer, which contains the aqueous layer. Then add the upper layer, which contains the organic layer, to beaker number 2. Now we have 2 beakers. Beaker number 1, the lower layer, contains salts with water, the aqueous layer. The second one, organic layer, contains benzyl alcohol in the ether. Now to this beaker, drop by drop, add 1 ml of concentrated HCl. By this addition, potassium benzoate will convert to benzoic acid. Then filter our white precipitate by using Buchner funnel. Wash with excess of water, then dry and calculate the yield of benzoic acid. Now let's purification the beaker number 2. Let's talk about purification of benzyl alcohol. To this beaker, add 10 ml of saturated sodium bisulfate to remove unreacted benzaldehyde. This organic layer contains benzyl alcohol, ether, and maybe another organic material like unreacted or excess of starting material, which is benzaldehyde. To remove this unreacted benzaldehyde, we have to add sodium bisulfate. So sodium bisulfate reacts with benzaldehyde to produce alpha hydroxybenzyl sodium sulfonate, which is soluble in water. Now, maybe we sometimes add excess of sodium bisulfate. So to remove the excess of sodium bisulfate, added to the beaker number 2 another 20 ml of sodium carbonate solution. So sodium carbonate solution will react with the excess of sodium bisulfate to remove the sodium bisulfate from the beaker number 2 solution. Now, after 2 addition sodium bisulfate and sodium carbonate solutions, now we have another 2 layers of aqueous layer and organic layer. Now, the organic layer must contain just ether and benzyl alcohol. Now, repeat the separator process again, and the second layer, which contains just ether and benzyl alcohol, add NGSO4 as a drying agent, and then evaporate the ether in the water bath, so only will remain benzyl alcohol as a pure material, pure product. The second solution, water solution, consists of sodium carbonate, sodium bisulfate, or alpha hydroxybenzyl sodium sulfonate, or sodium sulfate. So this is well ignored by the second aqueous layer. This is procedure for Cannizzaro reaction. We'll divide it to 2 parts. Part 1 from point 1 to point 5 will be preparation of benzyl alcohol and potassium benzoate. Part 2, it's work up to purification our product, benzyl alcohol and potassium benzoate. At the final, we will get 2 material of benzyl alcohol and benzoic acid. I hope this lecture was clear. Please read this experiment, the principles and procedure, and expect live meeting this Thursday at 2 p.m. If I check and find that a good number of students have reviewed this lecture and lecture number 1, so I will make a live lecture to discussion aldol reaction and Cannizzaro reaction. After this live lecture, I will give you inshallah some of homework, some of questions, and I will explain some important questions about these 2 experiments. If you have any questions about aldol or Cannizzaro or any subject in organic, ask me via emails, and see you again. Bye bye.